So if you paid attention to the last slide, which I'm sure you did, you notice that the laws of logarithms are parallel to the laws of exponents. It's because exponents can be called logarithms. They're the same thing, just written in a different language. These are four of the most basic rules. There are other rules, but we're just going to work with the basic ones today. If we are multiplying, we can accomplish that by adding the exponents on the same base. Likewise, if we're dividing, we can accomplish that by subtracting the exponents on the same base. This rule that gets used a lot in practical problems, a logarithm is an exponent. So we're taking the exponent of something being raised to a power. Powers of powers, we can rewrite that as multiplying with the exponents. So we would have this exponent times that power. Some people just learn to think of it as sticking the k out front. That's fine, but we really are multiplying exponents to take powers of powers. The last one is pretty obvious. We've got the same base, we've got the same answer. The only way that can happen is if m equals n. And that's the one we're going to start with because it's so obvious, actually. So if we know that the log base 3 on 10x, it's supposed to be a 3. On 10x equals log base 3 on 42. The only way that can happen, since the bases are the same, the answers are the same, is if 10x equals 42, or x equals 4.2. If it's not log base somebody or other, if it's ln of x plus 5, which really is log base e, equals ln 14, only way that can happen is if x plus 5 equals 14, or x equals 9. In calculus and in chemistry and a lot of other scientific studies, it's often easier to do further mathematics with these things if we break them into many little pieces, using the laws of logarithms. So on the first one here, we have got a power of something being raised to a power. Now this whole thing is being raised to the 4th power, so we can do that. We could make it b to the 4th over c to the 4th, and it just make the problem longer. It would work, but it would make the problem longer. So we're going to rewrite this power of a power as multiplication. But this is the same as 4 times log base 2 of b over c. And now, this is a division, and we can accomplish the division with powers of the same base if we subtract the exponents. So this is going to become 4 times, now I have to do an extra bracket here because it's going to be 4 times both parts. Log base 2 of b minus log base 2 of c. And trying to find the derivative or the integral is much easier when it's broken down like this. So let's try the next one. I'm not going to pull the 2 and stick it out front because not everybody here is being squared. Essentially, this is a division problem. That is the last thing you'd be doing, you'd be dividing. Up here, the last thing you'd be doing is exponenting. which I don't think is a verb, but anyway. So we can accomplish the division by subtracting the exponents. They're on the same base. We got log base 4, log base 4. And then within this first term here, we have multiplication. So we can rewrite that as log base 4 of a squared plus log base 4 of b minus, waiting for us is log base 4 of n to the third. But the first and last terms have powers within them. And those powers of powers, we can rewrite them as multiplication. So we can bring out the 2 and make it 2 times the log base 4 of a plus log base 4b minus, and we can pull this power out as multiplication, 3 times log base 4 of h. And somewhere in there my n turned into an h. Sorry about that. Let's try 2 more. This one doesn't have a base, so we know that means it's understood to be base 10. And we have this square root thing here. Well, we can express the square root as a power, and we do that a lot in calculus. Square root, remember, is to the 1/2 power. Well, now we're taking an exponent of something raised to a power, so that can be rewritten by pulling the 1/2 out front, which I totally forgot. On 5a to the 7th. So it's definitely getting broken apart here. Now within the parentheses, we're not going to pull out the 7 and stick it out front because only the a is being multiplied to the 7th power. So we can't pull the 7 out yet. Maybe later. So we have 1/2 times the log of, and we're going to put 1/2 with parentheses here, log of 5 plus the log of a to the 7th. But now, because this is an exponent of something raised to a power, now on that single term, we can rewrite it as multiplication 7 times log of a. And that's definitely stretched out. And the last one is log base a of this whole thing. Well, once again, it is basically a division problem. So we can break it apart as log base a of the numerator minus log base a of the denominator. I know it's a pain to keep writing all the little base a's, but it's necessary. And within each of these terms, we have multiplication. So we can write that as log base a of x squared plus log base a of y cubed minus, and I'm going to put extra parentheses here, log base a of m plus log base a of n, because all of this is part of the subtraction. And then finally, we can take care of these exponents here. Power of a power, we can write it as multiplication. So we'd have 2 times log base a of x plus 3 times log base a of y. And if we want to, we can distribute the negative 1 here, minus log base a of m minus log base a of n. And we have definitely expanded. Well, now that we've gotten practiced at tearing them apart, they'd like us to push them back together again and come up with just one single logarithm. Log of this lump. Okay, we have a 6 on the outside as a multiplier, and I'm hoping you're getting the feeling by now that this is going to become some kind of exponent. We can either distribute the 6 all the way across and then deal with the pieces, or we can deal with the part inside the parentheses and then deal with the 6. It's probably faster to deal with inside the parentheses first when you're trying to condense it. So we'll leave the 6 out there. And then if we're subtracting exponents of the same base, we're actually accomplishing division. So this would be 6 times the log base 8 of 5 divided by m. And I'll put parentheses around it because of the fraction. And now we can apply that if we were multiplying with exponents, we were actually taking powers of a power. So this is going to be log base 8 of 5 divided by m raised to the 6th power. We could make this 5 to the 6th over m to the 6th, but we're trying to get it as condensed as possible. So we would leave it like that. On the next one, they're all just 3 separate terms. So we can deal with each term as it comes. Multiplying with exponents implies powers. So we're going to write this one as log base 3 of x raised to the 4th power. Plus, and this one, because we're multiplying with exponents, it's going to imply a power. So this would be log base 3 of y to the 5th power. And minus log base 3 of z. Well, adding terms implies that there's multiplication. Subtracting logs, which are exponents, implies division. So we can rewrite this as one big log, multiplying the x to the 4th times y to the 5th, and dividing by z. The last one's going to be a lot like the first one. Once again, we are not raising the whole thing to the 1/3. We could distribute the 1/3, but that won't make it any easier. So the 1/3 is just going to sit there while we do inside the parentheses first. Now within the parentheses, we are multiplying with exponents, which implies there's a power there. So this will be log base 2 of b raised to the 4th power. It's supposed to be 4. Plus log base 2 of t. Now still inside the parentheses, we have the same base. We added the exponents, so that implies that there was a multiplication going on, that this is the same as log base 3 of b to the 4th times t. And then, so that's as simple as the inside's going to get. But this 1/3 out front, when we multiply with exponents, that means there was a power. So this would equal log base 3 of b to the 4th t raised to the 1/3 power. For some problems, we would leave it like that. Your book tends to want to change this fractional power into a root, so they may write it, you may see it written with them as the cube root of b to the 4th times t. Now that we've had some practice, would you please go to the next slide and find your assignment, which happens to be out of the textbook. On page 66, you'll see the laws of exponents written out very similarly to the way we have them. On page 67, they have a few more examples, and then they ask you to do the try these.